All right, folks. Video 2, quiz 2 on finding displacement, speed, and velocity from graphs. Another thing that I wish I had typed in or kind of put in the title is not just displacement, but also distance. Where displacement, this one is the difference between your starting and ending place, but distance is how far you've traveled total. So, for instance, I go around a circle, right? And I start and end at the same spot, my displacement is 0, but my distance is whatever the heck this circumference of the circle is, right? So kind of interesting. This might be where you're feeling right now, as far as this adorable looks like Labrador with a tie. But hopefully after today, tomorrow, you're feeling kind of better with what we're doing as far as kind of the basics of what is simple harmonic motion and how does it actually work. This picture is just hilarious. So we have a graph of some mass of displacement over time. It's a mass attached to a spring. What's the velocity at 1 second? Well, really looking at this displacement, this is really like x, and time, that's t. Well, thinking back to actually the first week of our school year, we kind of learned that velocity is the change in displacement over the change in time. Well, if this is like my y thing and this is like my x thing, well, the change in rise or the change in run, that's just the slope. So the slope of this graph is the velocity. So when it asks what is the velocity at 1 second, well, I look right here at 1 second as I go up the graph and I see that, hey, it's flat right here. So since it's flat, that means the slope is 0. So there we are. That's it. The next one, we have a mass on a spring, a graph of the displacement over time. What's the average speed? Average speed between 1 and 3 seconds. Now, I kind of gave a hint here as well, and it says that speed is the magnitude of velocity. So since it has no direction, then it's just a number. So since it's a magnitude, really, we're just going to take the absolute values of it. So that already tells me that we're not going to have either of these answer choices with the negative, that those are wrong. Because since it's speed, it's just going to be a number. That's it. So, and we care about between 1 and 3 seconds. So I see 1 second is right here. 3 seconds is right here. And we know that velocity from before is the change in displacement over the change in time. But speed, since it's just the magnitude, I could just do that, take the absolute value of it, and we're done. So really, if I look right here, my rise is 1, 2, 3, 4, 5, 6. So we've gone 6. Really, it's -6, but we're going to take the absolute value, but we'll put that even there still. So -6 over 2. So we get the absolute value of -3 centimeters per second. So we get 3 centimeters per second, since it's the speed. If it asks for the velocity, then it would be that -3, since velocity has the directional part. And in this case, if it's going from here to here, it's going down in the negative direction. So we have another mass on a spring. Oh, what do you know? And a graph of its displacement over time. What's the average velocity now? So before we wanted speed, now we want velocity, and we want it between 2 and 5 seconds. So I'm looking over 2 seconds, my mass is right here. 5 seconds, my mass is right there. And now here's the kind of weird thing. Velocity depends on displacement, not on distance. I know it sounds like I'm splitting hairs, and I want to apologize, but here's what I really mean. At 2 seconds, it's at 4 centimeters. At 5 seconds, it's at 7 centimeters. So that tells me that our displacement here, our change in x, is really 3 centimeters. That's the displacement. If I'd asked you for the distance, though, well, we'd have to go, okay, well, it went from here all the way to here. So it's gone from 4 to 1 centimeter. So it's moved 3, and then it's gone from, so this would be 3 centimeters. And from here to here, that's 6, because it's going from 1 to 7. So 3 plus 6, well, then we have 9. But that's not the case. Since we want the average velocity, we just care about the displacement. So really, I have 3 centimeters of displacement change, and in time, we have from 2 seconds all the way over to 5 seconds. That's 3 seconds of time. So really, our velocity here is we have a displacement change of 3 centimeters and a time change of 3 seconds. So that gives us 1. And since it's going from a smaller to a bigger displacement, it's going to be a positive. So 1 centimeter per second. Alrighty. And I think this is our last one on here. So we have another mass. It's on a spring. What is the distance traveled between 0 and 2 seconds? Oh, no, there is another question. So we want the distance traveled. Now, keyword here is distance, not displacement. Distance is like how far it's moved total. Kind of remember going around in the circle here. If I started in at the same spot, my displacement, my delta x, is going to be 0. But my distance, kind of, if we're thinking about our previous unit on torque and rotational motion, kind of our arc length, really that delta S, because our angle here, we've gone through 360 degrees, and we have this radius here, so our arc length would be whatever that circumference really is for it. And so what is the distance traveled? Well, from 0 to 2 seconds, 0, we start at 4, and then we've gone all the way up to 7. So we've already gone 3 centimeters. And then to 2 seconds, we're down here. We've gone another 3 centimeters. So if we've gone from 4 to 7, that's 3. And then 7 back to 4, that's another 3. Well, we've moved 6 centimeters. And then this one's actually giving us, it's the same in graph, but it's asking what is the displacement of the mass from its starting position that should say 2 seconds, not at 2 seconds. I done goofed there. But we want the displacement. So if we're starting here and we're going to 2 seconds, this is almost just like the question above. The question above said the distance from 0 to 2 seconds. Now we want the displacement from 2 to 2 seconds. Well, if I look here, we start at 4 centimeters, and then at our kind of ending time, we're at 4 centimeters. Well, we've gone no displacement. We are displaced nowhere. So we got to pick 0 because we're right back where we started. And that is it. So this is actually kind of a review almost of really Unit 1 a little bit, but kind of getting better at reading these graphs and what they kind of tell us.